Hello everyone. Now I'll be showing you how to do homework 6 of your software analysis and design course. So to start doing the homework, we first need to navigate to the course website and go to your homework 6. So this is your homework 6. So just click on the required homework assignment. Okay, so now you can find your homework assignment. So each student should become proficient with manual calculations so as to have to manually calculate all these values, and also to become proficient with automatic calculations. And you should create an Excel workbook and you should include several worksheets. So each worksheet or each tab should include a table with numeric values of data and cost benefit analysis diagram. Like each worksheet should include a table as well as a diagram, break-even analysis diagram. And then so all the Excel files with 8 tabs should be named using file naming convention in this course. So the file must be emailed to the instructor. So these are the requirements which you can find on your course website. And if you just scroll down, so here we have the homework assignment for cost benefit analysis. So if we need to create a workbook in Excel and name it homework number 6. So and we need to include several worksheets and name them as homework 6, example 6, 8, 9, 10, 11, 12. So this is how I've named the files or the worksheets. Now we need to complete the exercises, putting all the required absolute values of the project, and we have to write formulas in Excel to calculate NPV of all costs, NPV of all benefits, ROI, break-even point, and finally we need to create a graph. Okay, so we are also provided with the outcomes for homework 6, example 6 or exercise 6. So these answers are also provided so that we can verify our solutions with these answers and make sure that we have everything correct. Okay, so it's mentioned that if and only if the results are same, then complete additional exercises. So let us see what the exercises exactly are. So we have exercise 6. So you can find this on page 145 of your textbook. So here we are given the question, like we have to assume the monetary benefits of an information system as $85,000 per year, and one-time costs as $75,000, recurring costs as $35,000 per year, a discount rate of 12% in a 5-year project time horizon. Assuming all these values, we should calculate in Excel using formulas, like we should calculate the net present value of these costs, net present value of these benefits. We should calculate the overall return on investment, that is ROI for the entire project, break-even event as to when the exact break-even occurs, and finally we have to create a graph for the break-even event. So initially we have to execute this for exercise 6 with the values given, like 85,000, 75,000. With these values we should do the exercise 6, and then for this exercise 8 we should change the discount rate from the exercise 6. Here you can find that the discount rate is 12%. We should change this to 10% and then redo the entire cost benefit analysis. So for exercise 9 we should change the recurring cost to $40,000. Here it's $35,000. So here we have to change it to 40,000, and then again we have to redo the entire cost benefit analysis. So finally for exercise 10 we have to change the project time horizon from 5 years. So here we have it for 5 years. We have to change it from 5 to 3 years and then redo the entire cost benefit analysis. So similarly we are also provided with exercise 11. So here you have given the values for the exercise 11, and then we have small changes, like in exercise 11 we have the discount rate as 11%, and we have in exercise 12 it's changed to 12%. Similarly this 45,000 per year is changed to 40,000 per year, and we have an extra exercise where the time horizon is changed from 5 years to 3 years. So we have to redo the cost benefit analysis for these 3 scenarios as well. And as earlier we have seen that we have the solution for exercise 6, so we also have the solution for exercise 11. So if you are sure that all these values match with your values, you can proceed with the exercises 12, 13 and the extra exercise. Okay, so now let us see how to do all these calculations and how to fill the table. Okay, so this is the exercise 6. So first I've just created a table similar to this, and the information which is provided to us, it's like we have given the net economic benefit as $85,000 per year, one-time cost as $75,000, recurring cost as $35,000 per year, discount rate as 12%, and a 5-year time horizon. So this is all the information we are provided with. So now I've just added a table to this Excel, and I've given, since we have 5-year time horizon, I've given year 0, 1, 2, 3, 4, and 5, and I've entered net economic benefit. For year 0, it's $0, and for year 1, it's as $85,000. For year 2, it's $85,000 again. For year 3, $85,000 again. For year 4, $85,000 again, and for year 5, it's $85,000 again. As since in our question, it's mentioned that it's $85,000 per year, so it's not we don't have a different value for each year, but for all the years it's $85,000. And discount rate is given as 12%, so it's 0.12. I've just taken the discount rate as 12% over here, and to do the calculations to make it easy. So in order to find the formulas for these calculations, you can find them on your course website. So I'm just opening the topic 6. If you scroll down, okay, so here we have the net present value. Okay, so we have the net present value. So net present value is nothing but sum of all present values across years, and we have the formula for the present value, which is y into 1 by 1 plus I whole power n. So first, with the discount rate, we are given as 12%. So I'm just calculating the 1 by 1 plus I whole power n. So I'm just calculating this part, the 1 by 1 plus I whole power n. So this is 1 by 1 plus I whole power n. Since I, it's nothing but the discount rate. So the discount rate, I'm just taking it as, I'm just entering it into a different cell, and then I'm taking this as a reference. So 1 by 1 plus I is nothing but your discount rate, that's 12%, whole power n. And so this I'm doing for year 0, so my n will be 0. So similarly, 1 by 1 plus I whole power 1. So this I'm doing for year 1. So my 1 by 1 plus I whole power n value will be 1. So for year 2, it will be 2. For year 3, it will be 3. For year 4, it will be 4. And finally for year 5, it will be 5. So this is how we have calculated this discount rate row. Like we have incorporated the formula 1 by 1 plus I whole power n, where I is the discount rate and n is the number of the year for which we are calculating the discount rate. Like 1 by 1 plus I whole power n, for year 1 the value of n will be 1, for year 2 the value of n will be 2, for year 3 it will be 3, for year 4 it will be 4, and finally for year 5 it will be 5. So this is how we have calculated the discount rate. Now we need to calculate the present value of benefits. Okay, so to calculate the present value of benefits, we just multiply the discount rate like this value, the 1 by 1 plus I whole power n, with the provided net economic benefit. So we are calculating the present value, which is y into 1 by 1 plus I whole power n. This is our y and this is our 1 by 1 plus I whole power n. So the product of these two will be the present value of benefits. So our present value of benefits for year 1 is nothing but C5 into C4. C5 is the discount rate and C4 is the net economic benefit for year 1. Similarly, for year 2, it is D5 into D4. For year 3, it's the product of these two values. For year 4, it's the product of these two values. And finally, for year 5, it's the product of these two values. So this is how we have created our present value of benefits row. Now we need to calculate the NPV of benefits. That is the net present value of benefits row. So let us see how to do that. So net present value of benefits, as we can see over here, it's nothing but the sum of present values across all the years. So for year 0, it's nothing but the net present value of benefit. For year 1, it's sum of B7 plus C6, that is present value of B7, that is present value of this year 0, as well as C6, which is the present value of year 1. And for year 2, it will be C7 plus D6, that is since it's a cumulative value, like the sum of all PVs across all the years, it's nothing but this value plus this value. Finally, for year 3, it will be sum of all values until year 2 plus the present value of year 3. For year 4, it will be sum of all the values up to year 3 and then present value of year 4. And finally, for year 5, it will be sum of all the values up to year 4 and the present value of year 5. This is how we have arrived at the net present value of benefits for all the years, like overall net present value. So it's, as we can see once again, it's the sum of PVs across years. So it's 0 plus 75,893, 75,893 plus 67,761. So it's 143,000 plus 60,000, 204,000 plus 54,000, finally 258,000 plus 48,000. This is how we have arrived with this net present value of benefits. And finally, we just want the total. Total is nothing but the final NPV of the year 5. So I've just included it as G7, which is nothing but this value. Okay. So now we are also given with a one-time cost, which is $75,000. So that will be included only in the year 0 as it's a one-time cost. And then we are also given with a recurring cost of $35,000 per year. So I've included this recurring cost as $35,000 for years 1, 2, 3, 4 and 5. Sorry, 5. So we have entered the negative $35,000 as the recurring cost for all these years and negative $75,000 as the one-time cost for year number 0. Okay, so now again we need to calculate the discount rate. Since NPV, the formula for NPV, either it's benefits or cost, it's nothing but the same. Sum of PVs across years, and PV is nothing but present like Y, which is the current value of dollars into from n years from now based on the discount rate of I. So the formula for NPV is same, either it's NPV of benefits or NPV of costs. So we just calculate the discount rate as we have done earlier. So we just calculate this part, the 1 by 1 plus I whole power n. So as we can see, it's for year 0 it's 0, for year 1 it's 1, 2, 3, 4 and 5. So we have just calculated the discount rate as we have done earlier. Now we need to calculate the present value of recurring costs. We can see that PV is nothing but Y into 1 by 1 plus I whole power n. So PV is nothing but the product of these two values, like the recurring costs into the discount rate. So you can see that it's nothing but C10 into C9, discount rate into recurring costs, 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 and discount rate into recurring costs. This is how we have calculated the PV of recurring costs. Now we need to calculate the NPV of all costs. So here we are calculating the NPV of all costs. So we have to consider both the one-time cost as well as the recurring costs. And for this year 1, it's B12 plus C11, that is the NPV of year 0 as well as the PV of year 1. And for year 2, it's nothing but sum of the PVs or the NPV of year 1 plus your PV for year 2. Similarly, it's the sum of all the PVs until year 2 plus your PV for year 3, that is D12 plus 11. So it's E12 sum of all PVs until year 3 plus PV for year 4, sum of PVs for all until year 4, which is F12 plus PV for year 5. So this is how we have calculated the NPV of all costs. And finally we have the total as NPV of the 5th year. So that is the sum of PVs of all the 5 years. And I've just entered it as G12 as this is the same value. Okay, so now that we have the NPV of all benefits and NPV of all costs, let us see how to calculate overall NPV. So on your course website, you can even find a demo. So you are provided with certain formulas. You can just use it as a reference while doing this. So now we need to calculate the overall NPV, and the formula to calculate this overall NPV is nothing but it's the sum of the NPV of cost and NPV of benefits. So this is H7 plus H12. So H7 is nothing but sum of NPV of all benefits, and this is sum of NPV of all costs or NPV of all benefits and NPV of. So the sum of both these values, that's H7 plus H12, gives the overall NPV, nothing but the NPV of costs plus NPV of benefits or NP of benefits minus NPV of costs. Since this is a negative value, so it's nothing but sum of these two values you can get the overall NPV. Okay, now we need to calculate the overall ROI. So here you can see that the formula for overall ROI is overall NPV by NPV of all costs. So it's nothing but overall NPV, which is H13, by NPV of all costs, which is H12. But we want the ROI to be a positive value, so we can either use absolute or we can just use one more negative symbol while using the formula. You can just write absolute value of H13 by H12, or you can just write minus H13 by H12 since we don't want the ROI to be negative. So this is how we calculate the overall ROI, which is overall NPV by NPV of all costs. Now that we have completed with the NPV and ROI calculations, so we have to see the break-even analysis. Okay, so to do that, first we need to calculate the yearly NPV cash flow. Yearly NPV cash flow, it's nothing but the NPVs, like the PV of recurring cost for a particular year minus PV of benefit, or PV of benefit minus PV of cost. So for year 0, we have the yearly NPV cash flow. We have to consider even the one-time cost during the calculation of this yearly NPV cash flow. So for this we have it as B11 plus B8 plus B6. So B11, it's nothing but your PV of recurring costs. B8, it's nothing but the one-time cost, and B6, it's nothing but the PV of benefits. So we have to add these three values, that is PV of benefits, PV of cost, and your one-time cost in case of year 0 to obtain your yearly NPV cash flow. Similarly, for year 1, it is PV of recurring costs plus PV of benefits. PV of recurring costs plus PV of benefits. PV of recurring costs for year number 3, which is this value, plus PV of benefits, which is this value, year 6. So, okay, so we have to add those two values, E11 plus E6. Similarly, PV of cost plus PV of benefits for year number 4, and PV of cost plus PV of benefits for year number 5. That is how we calculate this yearly NPV cash flow. It's nothing but PV of costs plus PV of benefits. Or you can also do it as PV of benefits minus cost. Like, since we have it as a negative number, it's anyhow we are going to subtract the value. In case of formula, you can just give it as C11 plus C6. It's anyhow going to subtract your cost from your benefits. Okay, so this is how we calculate the yearly NPV cash flow. Now we want the overall NPV cash flow. It's nothing but the cumulative value. So for year 0, it's 75,000, and for year 1, it's 75,000 plus 44,000. So since it's a negative value, negative 75,000 plus 44 gives you negative 30,000. So for year 2, it's negative 30 plus positive 39. So you get positive 9,000. For year 3, it's positive 9,000 plus positive 35,000. So you get it as 45,000. For your year 4, you get it as 76,000. And finally, for year 5, you get it as $105,000. So this is how we have calculated the overall NPV cash flow, which is just the cumulative values of this yearly NPV cash flow. Okay, so we know theoretically that by looking at these values, that the break-even occurs between years 1 and 2. Since the overall NPV cash flow changed from negative to positive during this period, like we can see that this is a negative value and this is a positive value. So that transition occurred between this. So by looking at the values itself, we can tell that the project break-even occurs between year 1 and year 2. But that is theoretical. However, we just need to use certain formulas in Excel and show the calculations. So I've just arrived with a break-even Excel reference. Like, I've just used a column called break-even Excel, and I've given a formula such that I will get the exact cell address where the value changed from negative to positive. So among all these values, that is B17 to G17. So these are my B17 to G17. So I've just got the address of the cell where the values changed from negative to positive. So I've just written a formula using the general Excel formulas, using the if statement and match and is number. Using all this, I've just arrived with a formula to find the cell, the address of the cell at which the values change from negative to positive, and then using that cell address, I've just arrived with one more formula so that I can tell, like, project break-even occurs between year 1 and year 2. So I've just used this formula. Just a moment. Okay, so I've just used this formula to arrive with this, that the project break-even occurs between year 1 and year 2. If break-even doesn't occur, like if I don't have any cell over here, I've written like no break-even should appear over here, and then that into consideration. Here also I'll be getting a value like no break-even. Since here we have a D17 cell where the values change from negative to positive. Using that reference, I've arrived with another formula so that it shows that project break-even occurs between year 1 and year 2. Even this, I've just used all the basic formulas from Excel, like the indirect formula, indirect for references and all, and arrived with this formula. Next, we need to use the first year of positive cash flow to calculate the break-even fraction. So generally how we do this is like over here you can find the formula also. It's nothing but use the first year of positive cash flow to calculate the break-even fraction. So this is where the values change from negative to positive. It's just the difference of these two values, like 15,303 minus 9,139 divided by 15,303. So this is how we do manually. I've just incorporated a formula to do the same. So this is using this D17 cell address. I've just arrived with a formula which does the same as this 15,003, like subtracting 3,908.60, like minus 9,502 divided by 3,908.60. This is what this formula primarily does. I've just arrived with a formula which does the same. And then finally, we just want to know when the actual break-even occurs at manually we can just tell that since we have this break-even fraction as 0.76 and we know that the break-even occurs between year 1 and 2, we can just tell that this actual break-even occurs at 1.76. But I've also arrived up with a formula for this which exactly uses this Excel values and then which exactly gives us the 1.76 value. So using this mid, indirect and all these kinds of formulas, I've arrived with this formula which gives me directly the 1.76 value. So this is how, these are just the formulas which I've used. You can just do it as your wish. Like you can just use different formulas. You can come up with new formulas. Maybe no need to arrive with a break-even itself. And this, without doing this, you can try to directly incorporate formulas and calculate these values. So this is just my way of doing. It's not like a fixed thing that you should just use this formula. It's nothing like that. You can come up with your own formulas to arrive with these outcomes. And finally, we need to draw the break-even analysis diagram. So how we do that is, like, I've just drawn a table. This is the year 0, 1, 2, 3, 4, 5 and benefits and costs. I've just copied the values from this. So this is C7, which is nothing but your NPV of benefits. So you can see NPV of benefits for each year. Like for third year, it's this. For fourth year, it's this value. And for fifth year, it's this value. So using these NPV of benefits, I've copied them in benefits, and costs, I've just copied the NPV of all costs, but I've just copied it as absolute value because I just don't want negative values in the graph. So I've just copied the absolute values of all costs, like NPV of all costs, these values. I've copied this here, and then you can just select this and go to insert, and you can find over here line charts. You can just click on this and you can just select anything. Just a moment. You can just select on anything as you wish. Okay, so you'll be arrived with this, and you can just style it. You can just add axis, title, and then maybe data labels or anything else. You can just style it as you wish. You can just add the title as break-even analysis. Chart title, and you can include the axis titles as this we are doing it for dollars. And this is year. So this is how we arrive with the graph of the break-even analysis. So now that I have done for the first thing, like the exercise 6, similarly you should do it for all the other exercises, like exercise 8, 9, 10, 11. So all this, just there's nothing much difference. Like here we have used 12%, but in exercise 8 we'll be using 10%, and for exercise 9 the difference is like we have using 40,000 instead of 35,000, and in exercise 10 we are just doing it for 3 years instead of 5 years. Similarly, you can do it for exercise 11 with all the given values. In exercise 11, the net economic benefit values will be different for each year. You can see it from your question, and by small changes you can just arrive with all these, and you can just zip it and send it to your instructor I don't think there is no need to zip also. You can just send it to your instructor before the designated deadline. Okay, so once again, I just want to remind you that all these formulas, it's not mandatory to use like this. It's just that I've arrived with these formulas. You can arrive with your own formulas using the basic Excel formulas. Okay, thank you so much.